So let us start. So we'll be solving some of the problems based on Lami's theorem. So before proceeding, right, so I strongly suggest to learn something related to the triangles, because the questions are actually mainly framed based on the properties of the triangles. So I'll just brief through those properties so that actually you'll be able to understand all the problems very easily. So Lami's theorem. In that, the properties of triangles are so there are actually different kinds of triangles. So that is, suppose if you take a triangle like this, and on this actually there are different kinds of centers. So one is circumcenter, and the second one is orthocenter, third one is centroid, and the fourth one is the incenter. So these are actually the centers actually we have to be aware before solving the problems related to this particular topic of Lami's theorem. Now the circumcenter is nothing but the center actually, if you draw a circle by touching all the corners, right? Now this circle is actually touching all the corners of this particular triangle. Now this center is called as the circumcenter of the triangle. This is the circumcenter of the triangle. Now the way we construct this center is, so this has to be taken the perpendicular bisectors of the sides. So a circumcenter is nothing but, so the circumcircle is having a center called circumcenter, which is the perpendicular bisectors of the sides. Perpendicular bisectors of the sides. That means, so for this particular side, identify the midpoint and then try to draw a perpendicular at the midpoint. So this is how actually you need to draw. So here actually this is at the middle, at the same time this is at 90 degrees, this line. So this is AC by 2 and this is also AC by 2. So this side length from here to here it is AC by 2, and from here to here also this is AC by 2. And similarly for this one also construct a perpendicular bisector like this, and for this also construct a perpendicular bisector like this, and the intersection of all the three perpendicular bisectors is nothing but the circumcenter. So this is the circumcenter. Got it? So the fundamental property of this circumcenter what we are going to use is the circumradius. So circumradius is nothing but this length. So this is usually represented with a letter called capital R. So this circumradius, if you draw a line from the center to the corner, from this center to this corner, or from this center to this corner, if you draw it, all the lengths are same. So this is called as the circumradius. Got it? Understood? Do you have any questions on this circumcenter? Any questions? Okay, so you can note down this. Then actually, if you are done with it, so I will go with orthocenter. Now, orthocenter for a triangle is nothing but the perpendicular lines drawn to the opposite corner. So now actually orthocenter so this orthocenter is defined as the perpendiculars drawn from the side to the opposite corner. For all the three sides. So all the three sides are concurrent. Concurrent means which will meet at the same point. And the concurrent point is called as the orthoradius for orthocenter. Now this orthocenter is nothing but draw a perpendicular to this particular side like this and draw a perpendicular to the opposite side like this and draw a perpendicular from here also. The only difference from the previous one is it may not meet exactly at the midpoint. It may be somewhere. But the condition is it has to be perpendicular here. So this center is called as the orthocenter. Earlier, these lines are actually no need to touch the opposite corner in case of circumcenter. But it has to be perpendicular and the perpendicular has to be drawn only at the midpoint. But here it is a little bit different. It has to be perpendicular and has to pass through this one. So there will be only one perpendicular for this particular line which can pass through the opposite corner. So that will be this line. Got it? Exactly the same line for here and the same line for this one. So this is the orthocenter. Got it? Do you have any questions on this? So this is about the orthocenter. And the centroid is nothing but so this is centroid is the concurrent point of the medians from all the sides. So this is nothing but identify a midpoint of each side and try to draw to the opposite corner. So this is the midpoint. So this is BC by 2 and this is again BC by 2 and this is AC by 2 and this is AC by 2 and this is AB by 2 and this is also AB by 2. Yeah. Sorry. So this one, yeah, this is the correct one. Got it? So this is actually the centroid. Centroid actually from the side, identify the midpoint and try to draw a line to the opposite corner. Now this one also. This one also. So this intersection point is called as the centroid. And the centroid property is, let us say this centroid is O and then the area of triangle BOC is equal to triangle COA is equal to triangle COA and AOB. So these areas are same. That means the entire mass of this particular triangle is concentrated at this particular point. Yeah. So in case of circumcenter, so this is how it is. Circumcenter, the perpendicular, but it has to be drawn exactly at the midpoint, like this. It may not reach the other corner. Got it? So this has to be at the midpoint and it has to be perpendicular. Got it? So this is the circumcenter, this is the orthocenter, this is the centroid. Any questions? Done? Noted? And the last one is the incenter. So incenter is nothing but angular bisectors intersection point. Incenter. This is the angular bisectors intersection point. So this is angular bisectors intersection point. So this is A and this is B and this is C. Now for this angle, draw a line which is exactly mid to this particular angle. So this is B by 2 and this is angle B by 2. And similarly here also. So this is C by 2 and this is C by 2. And here also. So this is A by 2 and this is A by 2. So the line which is drawn from the corner bisecting the angle to the opposite side, for all the three angles, it will be concurrent. So this concurrent point is called as incenter. Why we call this as incenter is, for incenter, so you can draw a circle by touching all the three different sides. So like this actually you can draw a circle in case of incenter. And this radius is called as the in radius. So this is in radius. And this is usually represented with the small r. So circumradius is represented with capital R and in center radius is, so in radius is represented with small r. But in case of orthocenter and in case of centroid, you cannot draw a circle. Got it? So incenter and circumcenter, these are the only two centers where you are drawing a circle on top of it. So this is how, if you draw it, this is capital R. So this is capital R and this is circumcenter. And this is small r and this small r is nothing but incenter. In case of equilateral triangle, all the sides will coincide. In case of, so this is an important point, in case of equilateral triangle, all the centers will coincide. So this is one of the important property. Got it? Understood? Or do you have any questions related to this geometry? So all these things are actually fundamental to understand Lami's theorem, because it will based on this properties actually he will be asking the questions. Yeah, great. So, and one more important circle property what we are going to use in case of this Lami's theorem is, if you draw a circle like this and then let us say this is the center and then this is a chord, then the angle made at the top, let us say this angle is A, then from the same chord, actually, if you draw a triangle like this, and this angle will be how much? This is one of the important property we are going to use. It will be double. So this will be 2a. So this property, you can prove it. So let me prove that. So if you draw a line like this, and then I call this angle as x. Obviously, this will also be x because actually this is a radius and this is also a radius. So this is a radius and this is also a radius, and if this is angle x, then this will also be angle x. So if this angle is y and this angle is also y, and if this angle is z and this is also z. Now actually this angle, if you calculate, this will be pi minus 2x, because in a triangle all the three angles should be equal to 180 degrees. So 180 minus x minus x. So 180 minus 2x is this angle. Similarly, this angle is pi minus 2y and this angle is pi minus 2z. Now in a closed circle, the total angle incurred is 360 degrees. That means if you add up all these three angles, it should accommodate to 360 degrees. That means pi minus 2x plus pi minus 2y plus pi minus 3y is equal to 2 pi. So this is 3 pi minus 2 times of x plus y plus z is equal to 2 pi, or 2 times of x plus y plus z is equal to pi, or x plus y plus z is equal to pi by 2. So this is one equation. Now, so we want to calculate this value. So this value is nothing but pi minus 2z. So pi minus 2z you can calculate as pi minus 2 times of z is nothing but pi by 2 minus x minus y. So this will be pi minus pi plus 2 times of x plus y. So pi will cancel out and this will be equal to 2 times of x plus y. But this angle is, angle A is equal to x plus y. Hence, obviously, this angle is nothing but 2 times of A. Understood? Okay. So these are the some of the important properties. So these are easier only if you are already aware of it. So otherwise, actually for freshers, actually you just understand these basics. So now actually we'll go to problems on Lami's theorem. Note down this problem. A and B are two fixed points. In a horizontal line at a distance c apart. In a horizontal line at a distance c apart. Two fine light strings AC and BC of length B and A respectively support a mass at C. B and A respectively support a mass at C. Show that the tensions of the strings are in the ratio tensions are in the ratio B into A square plus C square minus B square is to A into B square plus C square minus A square. So can you prove that? So A and B are two fixed points in a horizontal line. So let us say this is point A and this is point B. So this is A and this is B in a horizontal line. So these are two fixed points at a distance C apart. So this distance is C. Two fine light strings AC and BC of lengths B and A. So this is C and this is B and this is A. So this is one string and this is another string. So the tension in the string is T1 and the tension in the string is T2. Respectively, support a mass at C. So there is a mass that is located at this particular point. So this is having a weight of W. So show that the tensions of the strings are in the ratio of, so T1 is to T2 is equal to, so this one, above ratio. So can you prove this? Use Lami's theorem to understand this problem. So this is angle A and this is angle B and this is angle C. So try to apply Lami's theorem on this, because the system is under equilibrium condition. That means all the forces that are balanced out at this particular point. Okay, so let me solve this. See this, if you draw a horizontal line like this, so actually the goal of this entire problem is, so as and when actually if there are only three different forces and all the forces are balanced out, that means he is asking us to identify the conditions for the Lami's theorem. So that is what you need to identify first. Then actually in Lami's theorem, the fundamental quantities are the angles between all the three different forces. Now here actually what are all the forces that are there? One is this force, which is nothing but the tension in the string in this particular direction, and this is also the tension in the string in this direction, and the weight towards the bottom. So there are three different forces now, and all the three forces are actually under equilibrium condition at this particular point. Now this one, this is the angle C. So that angle between T1 and T2 we have identified. Now we have to identify the angle between T2 and W and T1 and W also, so that you can apply Lami's theorem. For that actually you need to be identifying this angle. So this angle actually I have drawn a horizontal line like this. Why? Because he said that actually this is a horizontal line. If this is a horizontal line, if I draw a parallel line to like this, then obviously this angle and this angle are the alternate angles, and this angle is also the alternate angles. This is angle A, and this angle anyway you know that this is 90 degrees. So now actually we have got all the angles. So this is 90 plus A and this is 90 plus B, and this is angle C. Apply Lami's theorem on this, right? So to apply Lami's theorem, so T1 is this one, T1 by sine of 90 plus A is equal to T2 by sine of 90 plus B, and the same thing actually even you can apply W by, so sine C. So this is Lami's theorem. So sine 90 plus theta is cos theta. So T1 by A cos A is equal to T2 by cos B is equal to W by sine C. So T1 T2 ratio is nothing but, so this one T1 by T2 is cos A is to cos B. Got it? So cos A is to cos B. So cos A is nothing but B square plus C square minus A square divided by 2 times of BC is to cos B is nothing but a square plus c square minus b square divided by 2 times of AC. Now actually top and bottom, actually if you multiply with whatever is left over from here, that is A. This is also A. Now here also you multiply with B, and this is B. So these two will cancel out, and whatever that left over is nothing but the answer for us. Got it? The problem statement is very big, but the solution is very simple. Understood? Note down one more. A heavy small ring of weight W. A heavy small ring of weight W is free to slide on a smooth circular wire. Is free to slide on a smooth circular wire of radius A. Fixed in a vertical plane. Fixed in a vertical plane. It is attached by a string of length L. It is attached by a string of length L where 2a greater than L greater than a root 2 to a point on the wire in a horizontal line with the center. In a horizontal line with the center. So that the tension in the string is W into L square minus 2a square divided by a into square root of 4a square minus L square. So can you prove that? First try to draw the diagram, then you will be able to identify the required quantities. So this is again the application of Lami's theorem only. So not much complicated. First you need to identify the diagram and then identify the quantities that are needed for the Lami's theorem. So here actually one important condition actually he has given. This condition is very much crucial for us. Now see this. A heavy small ring of weight W. That means actually yesterday actually I have solved one problem. Not yesterday, day before yesterday. I have solved one problem related to this only. So a heavy small ring of weight W is free to slide on a smooth circular wire. So there is a smooth circular wire of radius A fixed in a vertical plane. So first we will draw a vertical circle like this. So this is the vertical circle. Now actually on this actually there is a ring that is sliding like this, right? So it is actually free to slide. That means actually it may slide or it may not slide. Now actually this is under equilibrium condition. So that one, a vertical plane, it is attached by a string of length L where 2a greater than L greater than a root 2. That means the L value, so it is attached to a string of length L, and one end of that string is actually fixed on a horizontal line like this. So this is actually one end of the string. Now actually another end of the string, so it is actually attached to a ring like this, and this ring is attached to this particular string. Now this ring is actually free to slide this like this. Now actually where it will stop, this particular ring, will it be here or here or here or here, or it will go here or here? Where it will be there? Should I draw here, here or here or here or here? So I'll name it, this is A, this is B, and this is C, and this is D, E, F, G, H. So where should I draw that string? Is that correct, whatever I have drawn? So I should draw at B. Why? So B is correct, but why? Because that is the only possible location. So if it is here, because it is free to slide, it will come back like this. But if I keep it here, right, it may go this side or it may go this side, because the L value is less than 2a and greater than a root 2, right? Greater than a root 2, right? So that's the reason actually the only possible value is here. So the ring is here. Now actually it was tied up with certain tension T on this particular string like this. So it cannot move further because actually this length is limiting. So it cannot stretch further. If it is here, it will come back. But if it is here, it will come back like this. And it cannot go this point because actually the length value is less than 2a. So this is the radius. This is the diameter. So this length is less than the diameter. If it is here, then actually it will stop there itself. If it is here, it will come back. If it is here, it will come back. It cannot go into this location because the L value is less than 2a, right? So hence it has to stop here. So now the system is under equilibrium condition. So this is having a mass of m. Hence the weight actually it will be acting downwards. And then there is one more important key force which we have not mentioned here. That is, as and when there is a touch to the body, there will be a counter force. That is nothing but the reaction. So even here also there will be a reaction, and that reaction will be always perpendicular to the surface. So that you have to keep it in mind. Now being this is a circle, the perpendicular drawn to the circle is nothing but the normal. So normal is nothing but the radial direction. So this is the reaction R. Got it? So this is the diagram what we need to think of. So if you identify this diagram, then actually it is up to you how to apply the Lami's theorem. Now you can start applying Lami's theorem on this. Got it? Yeah, try to solve it now. So here actually you need to apply geometry. So that's the only thing left over. So that's why actually I explained all the triangle properties. So let me call this angle as theta, and obviously this will also be angle theta because this is a circle. So this is one radius and this is another radius. So the chord actually is nothing but the length of the string. Chord will make equal angles always. So this angle is theta and this angle is theta. And then this angle, we can identify this angle. Right? How much is that angle? What is this angle? 90 minus 2 theta. So this angle is pi by 2 minus 2 theta. Why? Because you know that this is a right angle triangle. So if this is a right angle triangle, this angle will be 90 degrees and this angle is theta. Obviously this entire angle will be 90 minus theta. But in that actually if you subtract one more theta here, it will be left with pi by 2 minus 2 theta. So that is this angle, pi by 2 minus 2 theta. Now actually as per Lami's theorem we need three different angles. So there are three different forces. One is actually tension in this particular string and this is the reaction. and this is the weight. So between all the three forces, we need to be identifying three angles. So this angle is nothing but this is phi minus theta. Because, so this is a straight line, it will make 90 degrees, and from the straight line there is a theta left over. So phi minus theta is this angle. And then the angle between this one, this entire angle. So this entire angle is nothing but pi by 2 minus theta. So this angle is pi by 2 minus theta. So because this is 90 degrees, this is theta, this is pi by 2 minus theta, that is the angle between tension and the weight. And this angle is nothing but, this is 180 minus pi by 2 minus 2 theta. So pi minus pi by 2 minus 2 theta. Right? Pi minus pi by 2 minus 2 theta. So that angle is, so pi minus pi by 2 is pi by 2 plus 2 theta. So once you got all the three angles, now you can apply Lami's theorem. So Lami's theorem states that T by, so T is this opposite side angle, opposite angles is this angle. This is nothing but pi by 2 plus 2 theta. Sine of pi by 2 plus 2 theta is equal to R by sine pi by 2 minus theta is equal to W by sine pi minus theta, where this angle, so theta actually you can identify, this length is nothing but L by 2, and this is theta, and this angle, this is A. So you can express cos theta is equal to, so L by 2 divided by A, or L by 2A is cos theta. So this relation actually you can substitute at the end. Now you can apply and then solve it. Sin 90 plus theta is cos 2 theta, and this is R by sin 90 minus theta is cos theta is equal to W by sin 180 minus theta is sin theta. So you can express, so T by cos 2 theta is nothing but, so T is equal to W cos 2 theta by sin theta. W cos 2 theta by sin theta. So you can simplify that. Cos theta value you can find out like this, and sin theta also you can find out from this and then substitute in this location. W into cos 2 theta is nothing but 2 cos square theta minus 1 under root, 2 cos square theta minus 1 divided by sin theta is 1 minus cos square theta under root. So substitute the cos theta value and simplify it. Got it? Understood? Okay. Cos theta value I have given. So this is cos theta. So if you draw a perpendicular from here, this length will be equally divided, and this equal division, this will be L by 2 and this will be A. So this is hypotenuse and this is a right angle triangle, this is the base. So L by 2 and A. From there you can bring the cos theta value, L by 2A. So one more. ABC is a triangle. ABC is a triangle. Forces PQ are acting along. Forces PQ are acting along the lines OA, OB, OC. The lines OA, OB, OC. Are in equilibrium. Are in equilibrium. Prove that if O is the circumcenter, prove that if O is the circumcenter, of the triangle ABC, then P is to Q is to R is equal to sine 2A is to sine 2B is to sine 2C. And there is part 2 also. The part 2 is P is to Q is to R is equal to A square into B square plus C square minus A square is to B square into C square plus A square minus B square is to C square into A square plus B square minus C square. Can you prove these two? So this is straightforward. This is a triangle ABC, and then this is actually the circumcenter, and this is OA, and this is OC, and this is OB. So he said that there is a force acting on this, and this is P, and this is Q, and this is R. So PQR ratio we need to be finding out. So being this is the circumcenter, so for any circle actually, now actually we have proved that earlier, so the angle subtended at the opposite corner, it will give an exactly double the angle here. So this is 2C, and this is 2A, and this is 2B. Now you can apply Lami's theorem on this. So that is P by sine 2A is equal to Q by sine 2B is equal to R by sine 2C. So this is, you can straight away apply Lami's theorem on this and then try to identify this. So that is question number 1. And question number 2, you can apply this one. So this is 2 sin A cos A. So P is to Q is to R is nothing but 2 sin A cos A is to 2 sin B cos B is to 2 sin C cos C. Now we know the sine rule. Sine rule is nothing but A by sin A is equal to B by sin B equal to C by sin C equal to 2R. So this is the sine rule. Now you can replace, so sin A with A by 2R. So this is A by 2R, and this is B by 2R, and this is C by 2R. Now the 2 and 2R will be constants, and then you can cancel out because that is present in entire thing. So this is P is to Q is to R is equal to, so A into, so cos A you can replace as B square plus C square minus A square divided by 2BC, and similarly B into A square plus C square minus B square divided by 2AC is to C into A square plus B square minus C square divided by 2A, 2BC. Now actually numerator and denominator, if you multiply whatever is missing at the denominator, so this will be A square and this is A, this is B square, this is B, this is C square, and this is, so this is AB here, ABC. Okay. So now actually this one will cancel out. So whatever left over is our answer. Yeah. Got it? I hope everybody understood this. So all these things what you need here, it is the fundamental understanding of the triangle properties. ABC is a triangle ABC is a triangle. Forces PQ are acting along The lines OA, OB, OC are in equilibrium. The lines OA, OB, OC are in equilibrium. Prove that if O is the orthocenter of the triangle, prove that if O is the orthocenter of the triangle ABC, then P by A equal to Q by B equal to R by C. Can you prove that? Now this is orthocenter now. So you should be able to draw the diagram. So he mentioned clearly that, so that is orthocenter, right? So let me draw the diagram. See this. Let us say this is the triangle ABC. And then, so this one is an orthocenter. Orthocenter is nothing but it will be a perpendicular intersection point. So this is perpendicular. And again, this is also perpendicular. And this is also perpendicular. So this center is orthocenter now. So this is O. So ABC is a triangle, forces PQ are acting along the lines OA, OB. So this is P and this is Q and this is R. So these are the forces now. So you have to identify, to apply Lami's theorem, you have to identify the angles between the forces. So QR is force and this angle you need to identify. PR are the force, you need to identify this angle. And PQ is a force and you need to identify this angle. So somehow you need to identify those angles with the known values. So we know the fundamental rule. The sum of all the angles in a triangle is equal to 180 degrees. That is a very, very basic rule. And that plays very crucial role in almost all the problems. So here actually, let me give the idea. See this. So if you take this angle, how much angle it is? What is the angle in terms of the known angles ABC? You tell me the value of this in terms of the known angles. So the idea here it is to know this angle, you can identify this angle with the known values and you can identify the known angles here also, and then actually from there you can bring out this angle. So that is 90 minus C, that's correct. So being this is 90 degrees and in this triangle, so if it is 90 degrees, this is angle C, then obviously this will be 90 minus C, right? So this is in terms of the known values. Exactly in the similar manner, you can identify this angle as in terms of 90 minus B. If you know these two, right? If you know these two angles, then you will be able to identify this angle, because the sum of this angle and this angle is equal to 180 degrees. So angle BOC is equal to 180 minus the sum of these two, pi by 2 minus C plus pi by 2 minus B. So this is pi minus, this is pi minus B plus C. So this is pi minus pi plus B plus C. These two will cancel out and B plus C is nothing but pi minus A. So finally you got to know that this angle is pi minus A. Similarly the other angles also pi minus B and pi minus C. So if you apply Lami's theorem on that, then P by sin pi minus A is equal to Q by sin pi minus B is equal to R by sin pi minus C. So obviously this is P by sin 180 minus A is sin A. P by sin A is equal to Q by sin B equal to R by sin C. So you can apply sign rule on that. So A by sin A is equal to 2R and B by sin B equal to 2R and C by sin C equal to 2R. So A by sin A is equal to B by sin B is equal to C by sin C equal to 2R. So sin A can be replaced as A by 2R. So this can be replaced as 2R into E. So this R is different. I call this as 2R dash in that case. 2R dash into P by A is equal to 2R dash into Q by B is equal to 2R dash into R by C. So 2R dash, 2R dash, 2R dash will cancel out. Then P by A is equal to Q by B is equal to R by C. R. So this is the answer. Got it? Any questions on that? Understood? So what do you want me to put in place of sin A? So I hope you understood. Everything is clear here. So this sin A actually, so you can replace this A by sin A, B by sin B, C by sin C. You are just replacing those values. Yeah, you can replace that. So because actually these are all known, right? So this is a constant, plain constant. If you want to keep this constant, you can put it and replace it, or else actually you can leave that constant. So A is directly proportional to sin A. So you can replace, in case of A, you can replace A also. That will also go. Got it? So this is how actually you should be solving the problems in case of Lami's theorem. And this will be the last class for Lami's theorem. In the next class, actually, I'm going to start with equilibrium of forces in 2D. Right? So I'll be giving an assignment on this. So maybe you can wait for the assignment and try to solve on your own. So you should be able to done with it. Yeah. So if you have any questions, you can let me know. Done?